Okay. So you sent me some question, I think. Let me see. Okay. Question number 16. Where is 16 question number? In the PDF you have sent is 16, 17. Can you send me question number 16? Or 17. A bullet going with speed 350 meters per second enters a concrete wall and penetrates a distance of 5 centimeters before coming to rest. Find the deceleration. So what is given to you? What is given to you? Are you listening what I'm saying? Hello, hello, 1, 2, 3.
So, to who are you asking?
Like Harshit, I think Harshit has sent me the question. Harshit, are you there? No. Hello, 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 hello. Harshit, are you there? Harshit, are you there? Hello, hello, hello. Hello, hello, hello. Hello, hello, hello.
Sir, I am able to hear you. I think
Yeah,
he's not.
he has asked the question and he's not there. That's the problem. Okay, anyway, so what I will do, we will start the topic today. So we are done with the motion under gravity. We have seen all the possibilities, and we have already solved variety of problems. Okay, so today we are going to start the kinematics 2. So let me start kinematics. So the topics that we cover in kinematics 2 are projectile motion, and second is called the relative motion. In projectile motion, we are going to learn something called horizontal projectile, oblique projectile, and inclined plane projectile, and you can also say obstruction. Okay. Now, the next part is called a relative motion. So, in this particular chapter, we learn a relative motion in one dimension. Then we have relative motion in two dimension, and then again in two dimension we have something called a Riemann problem, river man problem, wind and plane problem, he has something called collision of projectiles and maybe something miscellaneous. In fact, distance of closest approach. So we have a topic in fact called velocity of approach, and we'll end the discussion. So these are the topics that we have to cover in kinematics 2. So we'll start with the projectile motion. Okay, so in context of course Earth surface, let's say this is the Earth surface, and we call vertically up like this. This is vertically up direction, and we know that gravity is acting downward, right? So we all know that gravity always acts vertically downward. Now, if you throw any projectile in such a way that it is not collinear with gravity or acceleration due to gravity, so the only condition for projectile motion is that the initial velocity of projection is not parallel to the acceleration due to gravity. If that condition is met, or in fact you can say, yeah, not parallel is a good way, then the path described by the particle we call, I mean, parabolic path, you can say. The particle itself is called projectile, and the motion thus described is called projectile motion. The path is actually called trajectory. So we'll use different terminologies here to understand. So the rule for projectile motion is that one must throw any object which is not parallel with g. That's the only condition. So you can throw horizontally, obliquely up, obliquely down, or whatever you want, but not parallel to g. So what is not allowed in this case is you cannot throw this way and you cannot throw this way. So these two directions are prohibited, because if you throw this way, it becomes motion under gravity. So if you're not throwing this way, then it is definitely a projectile motion. So what we can define, if the initial velocity vector, if the initial velocity vector is not parallel to acceleration due to gravity, then the path traced by the particle is called trajectory. The particle is called projectile, and the motion It describes is called projectile motion. So now these are the things which you need to know about projectile motion. Just a moment.
Sir, so hello, sir.
Yes.
Sir, I have a doubt that sir, in both these marks of x, upward direction and downward direction,
Mhm.
uh, so if the ball is moving like it is first going up and down, but it has a little trajectory in it, and it is like the path is if we look from very far away, then it is moving like a straight line. But if we look from close, it is like moving like a projectile motion.
Yeah, yeah.
Then so what
So
we have to
yeah, of course you have to do it from the frame to frame. So the frame in which you are observing, that will describe the motion. So it is quite possible that in one frame it is motion under gravity, and in other frame it is projectile motion. So that's not an issue. So the frame will let you describe the path, and the definition will be as per the frame. Okay. So it is quite possible that in one frame the motion will look like a straight line motion, and in another frame it will look like a parabolic path with some trajectory, or you can say projectile motion. So in fact that is a part of relative motion also, where we convert a two-dimensional motion into one dimension, and the moment we convert this into one dimension, it is easy to apply the formula of one dimension, that is motion the gravity. Understood?
yes, sir.
Okay. Yeah, so there is no absolute definition. Okay, so we cannot say this motion is 100% uh, projectile motion. So we cannot claim something 100%. Rather, everything depends on the frame of reference in which the observer is describing the motion. So you choose some frame first, you go there, and then you observe the phenomena, and then you start describing it. So what you will describe depends on what you like choose as a frame of reference. Okay, anyway, so let's go further. Next. So how we study the projectile motion? We need to understand certain philosophy. Okay. So what are the philosophy? So every vector we can resolve into mutually perpendicular direction. For example, let's say acceleration is something which is fixed. Let's say it's always downward, and then a velocity we can take something like having two components. So you throw something like this. Let's call this as u. Now the rule says that every velocity we can resolve in two directions. One, which is perpendicular to the gravity. If I call it theta, we can say this is u cos theta, and the other we call u sin
U
theta.
sin theta.
Now, what we need to understand that gravity or the acceleration changes velocity. That's the definition of acceleration. But the other rule says that acceleration can only change the velocity in its own direction, which means this g can affect this value, but not this value, because these are mutually perpendicular. So g cannot create its effect along u cos theta. So this component will be unaffected by this acceleration due to gravity. And that's the property of vector, that every vector cannot have its effect in the direction perpendicular to itself. And this property we can exploit in various ways. So based on this exploitation, we can solve question differently. Now, before we solve question for various category, let's try to play with this a bit more. So G is acting this way, and you're throwing something this way. Now again, it is not necessary that you must resolve U. You may think of resolving G as well. So if I call this angle as theta, this is also theta. So now G will have a component G sine theta, because this is 90 minus theta, and G will have component G cos theta like this as well. Now this component will change this value for sure, and this will develop one new value. So what will happen? This will create a velocity in its own direction, and this will affect the velocity in its own direction. So you will decrease in this direction, but a new vector will also develop in the perpendicular direction. So u and acceleration we can resolve into variety of ways depending upon how we want to solve the question. Now, what is important to actually learn or capture here, that the choice of direction is up to the person who is solving the question, and the selection is always taken in a way to make the calculation easier. So the u will change to some new value u dash, and in this direction some new value will develop v dash. Now v dash is developed due to this acceleration, and this is changed due to this acceleration. And when you do something in the mutually perpendicular direction, then every pair of event which are mutually perpendicular are also independent events, which means like one event cannot affect the other event. So the event we can deal independently using one dimension motion. Now that is the beauty of one dimension. So any complex motion or two-dimensional motion or three-dimensional motion can be dealt using the concept of one dimension, which we are already well versed with, by resolving velocity and acceleration into components. Now, how many components you need depends on
Two.
question. So for two dimension, we need two component. For three dimension, we may need three component. And how to resolve the vectors? So we always resolve the vector into mutually perpendicular direction. So what is the benefit of mutually perpendicular direction? By resolving into perpendicular component, we make them independent. What does it mean? It means one vector cannot affect or change another vector, and therefore for each component you can write the kinematical equation of one dimension, get the answer, and then recombine them using I cap and j cap, or j cap and k cap, or k cap and I cap, or something else also. and then proceed. So now before we solve a question, the notion that this projectile motion is all about solving question by converting any dimension into separate one dimension problems, and each one dimension we can deal separately, although we cannot see the event separately. What we see is the overall effect of all components together. But when it comes to analysis, we are always free to choose one direction at one time to analyze the motion. And why this is happening? Because of the component nature of vectors. So vectors can be thought as the effect of various component vectors which creates the overall effect. So it's a reverse engineering. So instead of dealing with vectors, we deal with their components. And why we do so? For the obvious reason, by doing so, by doing this, we reduce the complexity from two dimension to one dimension. That is the only reason. And this is the part which you need to catch up. Okay. So now
Sir,
as we progress, yes,
sir, I didn't understand this gravity one example. Sir, you took theta randomly, no?
yeah, randomly. So I just chose, look, let's say I'm throwing some object in that random direction, which makes an angle theta with horizontal. That is what I assumed.
It's a gravity component. Right.
Okay, yeah. So let's say I want to resolve uh, into a direction parallel to you and perpendicular to you. So you can see that in the first scenario, so the rule is, let's say you have two vectors. Let's think of this. You have two vectors u and a. So what we do is we do not alter a and we resolve u parallel to a and perpendicular to a. Like so, whatever is the direction of a, don't disturb, and then resolve u parallel to a and perpendicular to a. That's like first rule to solve question. The second rule says that let's say this is u, so don't disturb u, rather resolve a parallel to u and perpendicular to u. Depends on how it acts, I don't know. Now these are the two ways in which we can solve problems. And then these two will go together. These two will go together. Like you can
Okay,
write
so,
the
so
equation.
that means sine
Yeah,
theta value should be always parallel to that
yeah,
A, and the cos theta value should be always perpendicular to the given
correct,
vector.
correct. Yeah. So what, like it is like I am showing you two different choices that you can actually make. So to solve question, sometime we resolve velocity along and perpendicular to acceleration. That's the first scenario. The second scenario is don't disturb u and rather resolve acceleration parallel and perpendicular to u. And both the method will have its own benefits. Now the benefits will be in terms of reducing the complexity or solving the problems in variety of ways. Now these things will not be obvious in the beginning, but as I will progress in derivation various category of problems, you will realize that what I'm saying. So just wait for some time and let's see the magic of this notion. So the first thing first, mutually perpendicular vectors are always independent. Now, that's a big theory. I'll just mention here. Note. So to learn multiple dimension, like 2 or 3 dimension motion, this is the basic thumb rule. What is that rule? Mutually perpendicular vectors or component vectors are always independent.
Sir,
Yes,
sir, the component vectors do not affect
each
the
other.
okay.
Component vectors don't affect each other because it is like this. Try to understand this concept. Let's say this is a vector. So we can think that this vector can be replaced by two other vectors as per triangle law. But I can choose any variety of vectors, but I choose mutually perpendicular components. So this is my actual vector. Let's call A, and I'm calling this as AX. This is AY. And now from triangle law, we know that the sum of these two vectors will produce the same effect as this vector is producing. So the mutually perpendicular component can be the substitution for the actual vector. Other ways of saying this, we can replace this vector by these two separate vectors acting independently. And now what this will do and what this will do will be independent events. Now the question is, can we see those events? The answer
No,
is
sir.
no. We can only see the overall event, like we can see what is this event. And therefore, when it comes to analysis, we can mentally create those events as independent event, and then we join together the mathematical equations. So we'll see how. Now this is the essence of two-dimensional motion. And what is the essence? Resolving into mutually perpendicular direction. Okay. Okay. Sometime. Okay. This is the third case. So I have shown you two cases in which I fixed G. I do not interfere with G, and I resolve U. The other I have shown is the U is kept as such, and then the G is resolved. We have resolved G value. Now the third case, what it could be? So let's say we have a random U. Let's say I have a random G, not random G, random A accession. So let's say we have something random. Let me do truly random thing. So let's call U. You can see we have accession and velocity both in the two random direction, and I choose two direction which are mutually perpendicular, something like this. In random sense, and I call this random as x and y. So I need to mention what is this angle alpha, what is this angle beta. I need to mention everything. Now the moment I do so, if I want to solve this question, I need to resolve both of them. So I will have ux also, ax also, uy also, ay also. So I will have four different components. Can you tell me what is ux, by the way?
Sir, it's u cos alpha.
What is ax?
U sin alpha.
What is ey?
Sir,
U sin
cosine
alpha.
alpha. U sin alpha.
And what is ay?
A sin alpha.
A sin beta.
Ay. So if you resolve A in the y direction, it will be plus y or minus y.
minus is sin theta.
Yeah. So what is the idea? Like if you look at the three different situation, the idea was you choose two directions which are mutually perpendicular, and then you resolve every other vector. In the first case, the y was coinciding with g, so we resolve u. In second case, we kept the u as like my x-axis. So the ideas, like there are many ideas. You can always choose x and y axis as you wish, and you can resolve any vector, and every way of resolving into two mutually perpendicular component will give you the freedom to solve. So you are not confined by x and y. What I have shown here is a random x, a random y. It need not to be horizontal also. I can choose x at any random direction. I can choose x slant also. I can choose x horizontal also. So the idea is the coordinate system assumption all are like independent events. So you as a problem solver, or you as a person who analyze the motion, takes this liberty to choose the axis. And why every assumption will lead to the same answer? Because these are the mathematical tools. So event is one, but the mathematical framework we can choose many. So the event will happen in the same. Let's say if you jump from a building, don't do this. So the time you will take to reach the ground is fixed, no matter who is seeing you. So whether the person is looking from the airplane, or from the adjoining building, or from the ground, all will measure the same time you took to go from the top to the bottom. So the framework is for the sake of analysis, but event is well defined. Now there are some physical quantity which will be frame dependent, especially the displacement thing. But there are some physical quantity which always remains independent of frame of reference. The answer never depends on frame of reference, and that quantity is nothing but the time. So time is universally calculated. Time is only thing which remains independent of time frame. All other physical quantity, which is a derivative of displacement, will depend on frame. Now you may ask, what are the things which are derivative of displacement? I hope you know. The answer is velocity, which is the first derivative, and acceleration, which is the
Second
second
derivative.
derivative. So because the displacement varies from frame to frame, so their derivative will also change from frame to frame. But the only thing which does not depend on frame is calculation of time. Although this claim was refuted by none other than the great Albert Einstein, and he proved that even time can change from frame to frame, and he laid the principle of relativity. And in relativity we have something called simultaneity. Einstein said two different inertial frame will observe two different time for the same event. Now that is beyond the scope of JEE, and what we learned is called the Newtonian physics. So the theory of relativity is discarded for our syllabus. So when you go in BTech, then you may be introduced to the concept of relativity. So for entire syllabus that we are going to cover, our assumption will be that time is an independent variable and every frame gives the same answer. So I hope, okay, this will be stick to your brain. So what we learn is called Newtonian physics, and what we analyze is called the Galilean transformation in the honor of Galileo Galilei. So the Galilean transformation talks about the frame and calculation of velocity and acceleration and displacement. And what Einstein discussed is something called Lorentz transformation, which takes care of frame and the variability of time in various inertial frame. Okay, so that's not easy. So we'll restrict our discussion to Galilean transformation. So what is Galilean? Don't worry about this. Whatever you're learning is essentially Galilean transformation. Okay. So name should not affect you. You learn the concept as of now. And what I'm saying is the coordinate system, every system, like you may have heard about one or two coordinate system, they are roughly uh, more than 30 coordinate system. 30. Okay. Maybe more, I don't know. So we have more than 30 coordinate system, and out of 30 I have already shown you three systems which are prominent: Cartesian, polar, spherical, cylindrical. These four are very famous, but beyond this we have variety of other coordinate system suitable for different mathematical context. That is a part of advanced mathematics. If you do beyond PhD in mathematics, then you will come across those variety of coordinate system. Before PhD, you will see only few coordinate system. Till graduation, we need to learn spherical and cylindrical coordinate system along with Cartesian and polar. So these coordinate systems are very famous. Other are less known, but they are many coordinate system, not restricted to four. And the purpose of coordinate system is to give you a suitable framework so that you can express components. But it is not the only way to solve question. Like, of course, if you want to write something, you need some framework. So you choose X and Y so that you can express the component. So the choice that which direction you want to take X and which you want to take Y is not unique. So it will have infinite orientation. The only constant that you have is when you draw X and Y, they should be mutually perpendicular. So this must be 90. That's the only constant you have. which is the part of definition of Cartesian system. Okay, so having said so many things about the system, the coordinate system, the method to solve, let's go and actually solve the problem. So we will start with the first variety called horizontal projectile motion. So in this case, what we do? In this case, we throw the object parallel to our surface. That's it. So the initial velocity vector will be parallel to Earth's surface. Initial velocity of projectile will be parallel to Earth surface. That's the only thing we need to know. Now, if you want to throw something parallel to Earth surface, then will you throw near the surface or above the surface?
Above.
Yeah. So the moment you draw a surface, now when you throw something above the surface, so you choose some height h, and then let's say this is the object you're throwing. Ignore the dimension of object, as I always say. And then you choose some value. So like you can call it u or v naught. So since we started with the assumption of v naught, so let's continue calling it v naught. Now this is how you throw. But how gravity is acting? So we all know gravity is acting downward. So gravity is always capable of creating velocity in the vertical direction or changing velocity in the vertical direction. So to solve the question, we need to start with some coordinate system. And as usual, it is up to you to choose the x and y coordinate. Now, the selection of coordinates should be some in a way which is convenient. So you have to look for what is convenient to you. So in this particular case, the path of the projectile is going to be like this. So it goes forward and down. Now, what is difficult is to realize that the forward journey is an independent event. Why? Because gravity cannot affect the horizontal motion. Gravity can only affect the vertical motion. So how much you go farther towards the right in this case, it does not depend on gravity. Rather, it depends on V naught. Now, how fast you go down depends on gravity. So what is the role of gravity? It brings you down. And the moment you are about to hit for the first time, it is not that it will stop here. If the surface is really smooth, it will keep on bouncing like this. So it will bounce like this. So if the surface is perfectly rigid, it can bounce like this. It may go further and further. It may bounce to the same height also, maybe like this. So it is not that the projectile motion will end here, but our discussion will be between you throw and between the instant at which it is about to hit the surface, any surface. In this case, it is going to hit the horizontal surface. It is possible it may hit some other surface. So the idea is simple. Velocity is forward. Velocity is also downward. And now what is interesting that the velocity in the horizontal direction always remains the same. Why? Can you guess why?
Inertia.
Yeah, inertia. And also there is no acceleration in horizontal direction. So there is no one to change the velocity. So it is the inertia which will carry you forward. And you're coming down because of gravity. So gravity having a role to play in bringing the object down. Imagine if there is no gravity. What do you think? What will happen?
So it will be moving in the same path infinitely.
Correct. So that's why this motion we can reconstruct using two different motion. I can think that in the time you went from here to here, you travel this much horizontally and you travel downward. Okay. So what was the velocity in the downward direction at the beginning?
0.
Exactly. Now, when you drop some object, what is its velocity?
0.
Exactly. Now, this condition is exactly similar to the dropping the ball. Why? Because when you drop the ball, you do not give any vertical velocity. And horizontal velocity, we have just realized that cannot bring something down. So the downward journey is only function of vertical components. So we can say that any vertical displacement has nothing to do with the horizontal components and vice versa. So after what time you will reach bottom depends on only vertical values of components. V naught cannot decide vertical motion at all. So what V naught will do? In the previous case, when we were solving the motion gravity, the V naught was also 0. So when you release the ball, neither you give X component nor you give Y component, right? And it
Yes.
goes down. It goes down. Now, when you give V naught, it goes forward also towards right in this case. So by increasing V naught, what we can do? We can attain greater horizontal displacement. So the time taken by the projectile to reach the bottom has nothing to do with V naught. But where you land at the bottom, of course, it depends on V naught. So in fact, the answer for the time of flight in this case is similar to the question which we have solved already. What happens if you just drop the object? How much time it takes to go down? If you remember?
Under root 2h by g.
Correct. So what do you expect here?
Same.
Exactly the same. So V naught does not matter. This is what we need to realize. Understood? V naught does not matter. So how to solve these questions? Okay. So as I said, first is the choice of the proper frame of reference. So let me do the frame of reference part here. You can choose the point of projection, but it's good to choose from bottom. Now this is the my framework. Now by choosing the frame of reference, what we allow ourselves to be able to write the components. So how we proceed? First of all, we write the components of U and A. That is what you need to do. It's like a basic algorithm. So before you solve any question, make a habit of writing these four variables. The first two component of velocity and the acceleration, because that is going to determine everything else. Okay. So what is UX here? Can you tell me what is UX? What is UX here?
So UX, so
What is the initial velocity along x-axis, parallel to x-axis?
0.
Sir, you
It's V0.
V not.
Yeah. What is UI?
Sir, 0.
0.
What is AX?
Sir, AX is acceleration.
Yeah, of course, acceleration component in x direction.
0
And what is AY?
minus
Minus.
Yeah. Now, once you get these four values, you can solve any question. So your job is done. So we define some terminology. So we will talk about the time of flight. So the answer will not change. It's the same thing what we learned so far. It's called time for which the particle remains airborne. Same thing. So what we can say? So time for which the particle remains airborne. So how to find the time of flight? The answer is the calculation of time of flight depends on vertical component. So we have to think of vertical. So we have discussed something called displacement method, right? SY equals to which you can also write as y minus y naught. So for time, we always think of y component. We ignore the x component. So just solve for one dimension. So what is y? Y means y coordinate. This is what is y coordinate?
H.
Y means the final position. Final
Oh.
y coordinate.
Sir, it will be 0.
And what is initial y component?
H.
What is the ui?
0.
What is ay? What I'm saying is you need not to mug up anything. It doesn't matter which question you're solving, whether it's one dimension or two dimension. At one time, you apply the concept of one dimension. That's it. And so you get your answer. So this answer is h equals to half. And so we know the answer is 2h by g. So we
Sir,
will
so time always depends on only the y component, not the x component.
okay, this is something again, not a right statement actually. You need to realize like what happened after one time of flight. So So you went from somewhere to somewhere. Now, when you went from somewhere to somewhere, what are the variables or parameters which you can see is changing? For example, I can see one thing, that when it went from the top to the bottom, it traveled something, and in this traveling, the vertical displacement was only h, in fact minus h. So the vertical displacement in this particular case is only h, no matter how you have traveled, you know, horizontally. So we exploit the information that I had. Okay, for example, your actual displacement is this much, right? But do we know this answer? Do we know this value? No.
No.
Do we know how much you travel horizontally? No.
No.
So what do you know exactly? Vertical displacement. That how much you have coming down, you know the answer. H. And because the information that I can see here is H, I tried to exploit. So which formula will talk about the vertical displacement? The y component. So we are fortunate enough that the y component is doing the job. So whoever does the job, just use it. Is this clear what I'm saying? Is
Yes.
this clear? Understood?
Yes.
Oh. So now you know the time. Now once you know the time, you can find something called range. So what is range?
Horizontal displacement.
Correct. So range is defined as horizontal displacement for one time of flight. So which formula we have to use? Displacement formula. But in which direction? In x. So without thinking much, you can just use a formula. S equals to ut plus half t square. And instead of y, we have to write x. So we are looking for this answer. And because ax is 0, so everything will be 0. So we can say clearly that r is only ux into t. And what is ux? V naught.
We know.
So range is v naught. That's simple. Is this clear? Understood, guys?
Sir,
Sir,
yes, I have noted.
Are done?
sir, that blue line is the range.
No. The range is the horizontal displacement. Read the definition. So how much you have moved horizontally? This much.
So one time of flight means the for ball it will be only one.
Correct, correct. So the moment you are about to hit for the first time, that's called one-time flight. So after the hitting, it will do something more, but we are not considering that event. Okay. Understood.
Yes, sir.
Okay. So now the third thing which they will ask you is called the you can find the in fact displacement also. What is the displacement? The displacement is
Tan theta.
under root of h square plus r square, right? See, there are terms: vertical displacement, horizontal displacement, and actual displacement. So vertical and horizontal are components of displacement. When I say displacement, it means actual one. What is actual one? S. And you can substitute the value. Okay, so we have horizontal, vertical, and total displacement. And the fourth thing or fifth thing, like we can analyze something more. So let me analyze something more actually. So so let's say if you throw an object, this is the actual path. Where is left? Sorry. Let him come.
Hello, sir.
Yes.
Sir, the h, if h is not given, then we can find it by that range
No, if
formula.
if h is not given, then what you can do? You can't do anything. So they must give something at least. So they should give at least range or velocity. I mean, they should mention at least few variables so that we can find the remaining. Okay.
Yes, sir.
Now question is simple. Like to go from the top to almost bottom, the time taken is called time of flight. So what if you are not going to bottom? If you are somewhere here, so you will take some time t. So I can say this is the time t equals to t when you are here, and in that duration, you will travel something. So you travel from here to here, and then you travel from here. So you travel from so we want to know the a general x value and a general y value. So it will have x and y coordinate, and this is the y and x graph. So can you tell me what is the x as a function of time t and what is y as a function of time t? Can you find? No. Yes.
Sir,
Yes.
sir, I got disconnected now. Sir, what to do in this graph show?
Yeah. In this question, we are supposed to write the x and y coordinate of the projectile as a function of time t. That is, after any random time t, what will be your coordinate as per the chosen Cartesian system. So can you do this?
Yes, sir.
Yeah. So what is x? Let's say you're throwing with v naught. So what will be x as a function of time t?
Uh, Sir, it will be uh, x by v naught equals to t.
Okay. So x is how much? V naught into t.
Yes.
So you just apply the formula s equals to ut plus half t square, and that's because you're looking for x displacement and time relation. So use the displacement formula and just substitute. What about the y, by the way?
Sir, under root 2 y by g uh, equals to t. Under root 2 y by g equals to t.
Okay. What is the formula for vertical displacement, by the way? Tell me what is
Sir,
the
root
formula?
2 under root 2 h by g.
See, my question is what is the formula in terms of time t?
Sir, it will be t square g by 2 equals to y.
I mean, how come you forgot the basic formula? I'm asking first to listen carefully. What is the displacement formula in one dimension?
S is equal to ut plus half at t square.
Exactly. So can you apply that formula for x and y separately?
Yes, sir. Sir, I applied that only.
No. So if you apply what you're getting the y. What is y?
Sir,
I want what is y. Y equals to what you're getting. Tell me that
y
answer.
equals to t square g by 2.
That's wrong.
Sir, here uy will be 0. So minus h equals to minus half gt square. So
You're not at the bottom. You're at some random point. So you need to write displacement. You're not getting the point. How we write displacement? Final minus initial. Are you writing that? No. Displacement is defined as change in position vector. Are you writing the change in position vector? The answer is no. You are not writing.
so sir, I have to mention like y1 minus y2
What was the formula for a displacement in y direction? Do you remember?
final minus y minus y0.
So are you using that formula? Are you using that formula? The answer is no. So can you use that formula? The answer is yes. Okay, I mean there's a difference between knowing the things and applying things. So you're not able to apply anything. So you like you're supposed to just write this formula and just substitute the value. So final position is y, because that's coordinate. Initial is h 0 plus. How difficult is this? I really don't understand. Was it too difficult to write? Now this is the equation of y and x. Now, once you have the equation of y and x, you can always find the equation of trajectory. So, what is the equation of trajectory?
Sir, it is x square plus y square equals to a, sir, which you gave the vector.
You are saying anything actually. I mean, you are not applying brain at all. You are actually totally having chaotic mind as of now. So, not at peace, not able to see things.
So now what is the question?
I have written the question. What is the equation of trajectory? And we have discussed this trajectory part in kinematics, I hope in detail.
Yes.
If we had one lecture only for trajectory, isn't it?
The formula for trajectory was x square plus y
There
square.
is there is no formula for trajectory. Listen, trajectory is a concept which says that eliminate the common variable and derive it. So go ahead and derive it. Or you need to revise the entire concept of trajectory. You need to go back to the lecture also, because you have lost the sense of that entire concept. So here x and y having common variable t, and this t we need to eliminate. So one implies t we can write as x by v naught. And so what we do? So 2 implies y equals to h minus half g t square, which is x by v naught whole square. Now this answer is y versus x relation, and so it represents a quadratic equation of trajectory, and this is quadratic, and you can look and you can see clearly what is the coefficient of x square, plus or minus.
Minus.
So it is inverted parabola, and if you look on the left,
Yes.
so actually this is the actual mathematical parabola, but because we are taking only positive value of x, so we have to discard this graph. So what you get is this graph, and this is exactly this graph. And h is representing the height of the vertex. Okay. So the value of y and x relation is this much. This is a very often asked question in projectile, and this will give you the freedom to solve any question if you know the x. Okay. So if you put y equals to 0, what you will get? If you put y equals to 0, what you get? The x corresponding to y equals to 0 is nothing but the range. So exactly after traveling r, the y becomes 0. At x equals to r, y becomes 0. So if you use this formula, putting 0, h minus gr square by, you get the same answer, v naught 2h by g. Of course, that's the answer we know already. Now, what else they can ask? So they can ask you mathematically slope. So if you do a tangent to the curve, then the tangent makes some angle. In fact, you can say the tangent will give you the instantaneous velocity direction. So this v is the velocity at any instant time t. And if we say this angle as theta, then you can find tan theta also. In fact, minus tan theta because it's below the x-axis. So for slope, if you know the equation, finding the slope is very easy. So because y is so mathematically dy by dx represents slope, and if you differentiate, what you get? Minus gx by v naught square. And because I am representing theta below the x-axis, so slope is written as minus tan theta is minus gx upon v naught square. So you can also write the formula tan theta equals to so they may ask you question like find the slope at a distance x, like how much velocity vector makes an angle with horizontal when it is x away. You can solve like this also. So
Sir, I didn't
it is
understand
not
that
like
this one. That
pardon?
why do you take minus tan theta?
Yeah. So that's the rule actually. So if we have x and y axis, let's say you have graph here. This theta is positive, but if I take theta below the x-axis, we take negative because
Oh,
tan theta is
okay.
negative. So we can always think this as origin, some arbitrary origin in mentally, and you can think of x dash. You can draw some x dash parallel to this and y dash. So you can always do x and y at every point, and then think of the quadrant. So this is actually in fourth quadrant. So this velocity vector is in fourth quadrant, and so the slope we can take as negative.
A call from +917517.
Is this clear? So this is how we solve. But is this the only way to solve? The answer is no. There are many other ways. So we need to do something more. So what we are going to do is called velocity analysis. So I'm trying to show you all the perspective in which we can think. So what is velocity analysis? Every vector v,
Velocity in particular direction.
so every vector v we can write as vx I cap plus vy j cap. This is how we proceed. And then what we do is we apply the kinematical equation for each component separately. So vx we can write as ux plus axt I cap uy plus ayt j cap. And then we just substitute the value v naught plus 0 I cap 0 minus gt j cap. This is pretty easy answer. So why I wrote like this? Because when you solve a general question, which is not just horizontal, this will help. So always proceed this. Now you can see you have x and y component. Okay. So if you try to find the tan theta with horizontal, like what is the angle that the velocity vector is making with x-axis. So first try to interpret this graph. What does it mean? It is saying that at any instant, the v vector will have two components, one horizontal positive, let's call it v naught, and other is vertical down because gt is downward. So it is saying that the value gt is downward. And so the resultant of these two, called the actual velocity v, so this is called the v vector, which you normally write as vector form. This is v vector. So what is the angle it is making below the horizontal? This is horizontal. So you can add the value. The value will be tan theta equals to gt by v naught. This is the magnitude one. So tan theta we can write as gt by v naught. If you know the time t, I can find the angle. If you know the angle, I can find the time also. And in fact, we can derive the other formula from here also, because we know x equals to v naught t. So t we can write as x by v naught. And if you substitute here, it turns out to be the same answer, gx by v naught square. You can go back and check. So this is called the velocity analysis. The third part.
So
Finding
the v vector is equal to vx I cap plus vy j cap. So means in question also we have to proceed like that.
Yes, you must proceed this way. If you want to master this chapter, you have to proceed this way. If you want to just learn for some time, maybe for 1 week, and then forget everything, then what you are doing is really great. Okay. So kinematics is the most challenging chapter among all chapter of physics, and very few are able to master it. The reason is they do not want to come out of their like convenient way of solving question as they were doing last ninth and 10th. But if you want to master it, you have to learn all the method which I am trying to explain. So it's up to you. I will not force anyone, but I will expect everyone to follow what I'm teaching. So the mod of V is how much? So because we have component kinetics, V square plus,
v naught square plus gt square.
yeah. So if you want to know the final velocity, so velocity modulus at the time, or we can say what is the speed of impact. So if you want to find the speed with which it will hit the ground for the first time, so just substitute t equals to time of flight, because it will hit the ground when t is t, and we know the answer. So we call it a v final, and we write as v naught square plus g square t square, which is this much. So final velocity is and this is very much similar to what we have even seen before also, isn't it? But when we saw this formula before, we were throwing the
Yes.
object either up or down. And now here we have thrown the object right. So now something is coming from here, which is something very interesting. And what is coming here is that no matter how you throw, if you throw some object from a given height h in any direction with same velocity, it will reach bottom anywhere. I don't know where. It will reach bottom with the same speed. I mean, it can have any direction, but the speed will be always. So the final speed remains independent of how you throw it, like in which direction you throw. And this follows from the principle of conservation of energy. So what we are writing is basically conservation of energy. If you know your class 9th potential and kinetic energy concept, you can in fact derive it. So we can say the Ke initial plus potential energy initial equals to Ke final plus Pe. So let's call this as a reference, the bottom. So the reference potential is 0. So initial kinetic energy is how much? Half v naught square. Potentially, you know mgh, like h is the height from the reference. Final is half mv square, but potential is 0 because we are touching the reference. And if you rearrange, m will cancel out. So v naught square by 2 plus gh is v square by 2. Now you can multiply by 2. So v square equals to v naught square plus 2gh. So it is this. So what we can realize that no matter how you throw, the speed with which you will hit the ground will remain same. Now what will change? Velocity vector will change. Why? Because for every direction it will hit differently. So someone throwing down will hit like this. If you throw horizontally, now you have seen that it will hit somewhere at some angle, maybe like this. So as you move, oh, wait, just name it something. So as you throw differently, it will hit the surface differently. So as we throw, velocity vector will change, but its magnitude remains same, irrespective of the fact how you throw. In each case, the height is same. So you have same potential energy, you have same kinetic energy, so you will have same final kinetic energy. So it follows the principle of conservation of energy, or to be more precise, principle of conservation of mechanical energy. Okay, so these are the things which you can encounter. So not last, not the least. So we have something more actually. So now I'm trying to give you all the ideas that we have to face in this chapter of projectile. And I think still, if you haven't changed the way you have been solving question of kinematics, then you are going to be in big trouble very soon. So this is something new for you, and I'm suggesting that you must change the way you have been doing sums of kinematics. But it seems like you're not at all interested. So are you guys doing with the new method or the old method? Your class 9 method.
New.
Which method are you doing?
It's a new one.
Very good. So with the complexity of question, this will help you. If complex questions are not there, if it is really easy, you can manage. But that's not the thing for JEE Advanced. Now you may be asked something very random, like at a random instant, this is the velocity vector called v, and it makes some angle theta. So this v vector and this v, we talk about something called velocity triangle. We have discussed this in vector, but once again. So what is velocity triangle? So if you look carefully, the formula v equals to u plus at. So here the formula will change from v equals to u plus g vector into t. Why? Because a equals to 0. And this is nothing but a this follows the triangle law. What is triangle law? These two vectors add up to give you v vector. So every vector v is sum of initial and gt. So what is initial v naught, which you can draw like this? Now gt will grow with time. So as time will grow, this will become bigger and bigger. So this is gt, only value, right? The value. So now this line is always the v vector. And therefore we can solve many questions directly from this triangle. Like what is v? So you can say it is v square plus g square t square. What is tan theta? You can directly see the triangle gt by v naught. So there are various things you can do. But apart from this, you can see something very interesting. That v cos theta is same as v naught. So cos theta will have the ratio, which means the horizontal component of velocity is always same as v naught. And that should be the answer, isn't it? Because in the entire journey, v naught has not changed. So v is changing due to gt part, not due to the v naught part. So it is the gt which is creating a new v. So v cos theta is always equal to v, and this is the one of the foremost equation which we use very often. And what we say, horizontal component of velocity always remains same as initial horizontal component, and it doesn't matter where you are. So even before hitting the surface, your horizontal velocity will be how much? Only v naught. But you will also have something extra here, and that will be how much? gt. We know this vy equals to uy plus ayt. So you can add like this. And this we have seen. Where we have seen? You can see here. So the x component is v naught, and what is y component? Minus gt. So in the minus j direction, the answer is gt. So when you are almost hitting the surface, the t becomes
A call from DD03.
Sir, so this situation is valid for the point after we are kicking the ball, or after it is in the air. Means after these, like Vy equals to 0 after that.
okay. So moving forward. So many things to explore. It looks like it's a simple topic, but if you delve deeper, you can see there are a lot of things that we can explore. So now I will give you a third perspective, maybe fourth, fifth, whatever number, I don't know. And that is called displacement triangle. So what is displacement triangle? So the displacement triangle, if you remember, we know A is equals to ut plus half t square, but in two dimension we can write as delta equals to u vector into t plus half. So for projectile motion, we can write Now, what you need to realize that these terms are totally independent of each other. These are two different vectors. So you can always treat them independent. So you can draw this line separately and you can draw this line separately without worrying about what this is and what this is. And the resultant of these two lines will give you the third line. Okay. So the UT vector, let's say if you're talking about this particular case, the UT vector is always horizontal. Why? Because you have thrown the object horizontally. So UT vector will be always horizontal, but the value will be V naught T because that's what we are. And what you need to realize that gravity only works downward. So it creates a vertical line always equals to how much? Half GT square.
Half GT square.
And these two will make a displacement. This is called displacement, which I have been saying S. And because it's a horizontal, I mean, this is a right angle triangle. So writing S is very easy. It's half GT square whole square. You can use Pythagoras. Now, what you can see, if you look at the problem that we were dealing with, horizontal projectile motion, and suddenly we realize that this problem is pretty easy if you have this perspective. So if you are throwing this, from the height h with some initial velocity v naught, now what you can realize that this motion we can just ignore and think of two separate motion, because eventually I know you are at the bottom, so I can say that the time in which you moved horizontally, in the same time gravity pulled you down by exactly h, isn't it? So you traveled v naught t, in the same time you have been pulled exactly downward. So these are two different events. That's why you're here, right? Because these two resultant will bring you right. And therefore, if you compare, you can clearly see this is h, nothing else. And therefore, the t is how much? H by g. And what is range? V naught t. It's so simple. So with the concept of velocity triangle and displacement triangle, every formula we can derive quickly. Now, let's try to think that what is this location? This is the location at a general instant. So I can say that you have fallen down only by half GT square, and you have only moved forward V naught t. So what is the x coordinate and what is the y coordinate? This is y, this is x. So clearly x is V naught t, and you can see clearly y is nothing but h minus half GT square. Do you realize this? Yes or no?
Yes.
Is this clear? Is this clear?
Yes, sir.
Okay.
Sir, I have to note this part, sir.
Yeah, please note down. So you can see that there are plenty of things.
Sir,
Yes.
sir, so we can derive everything from the displacement and the vector triangle.
Yeah, but do not use in the beginning. First, you master the fundamental. Once you master that, then I will tell you, you can go back to this. Like I want you to master both of them, because one is the fundamental which will always help, and this is also fundamental, but I want to both Okay, I want someone should be good with both the methods. So is this clear?
Yes. Done, sir.
Hmm.
So I want to something. Noted, sir.
Okay. So now knowing the formula is not good enough. You need to know how to derive the formula, because every question of JE requires, solving from scratch. So that's the nature of JE advanced problem. Other problems also need either formula or doing from scratch, but because it's a huge syllabus, if you try to remember the formula, the chances you will forget after some time. But if you try to learn the method, you can always derive, even though you have totally forgotten what was the answer. So now that is difficult to realize in the short term, but because we have the experience, because we are teaching for a long time, you should trust my word. You will forget everything, but not the method. So learn how to derive and what to derive instead of learning the derivation and its results. So this is the very common mistake that every student commit in the beginning. They never trust their teachers. The reason is they cannot believe that this could happen. And when actually happens, they realize, oh, something happened bad. So you should have told us earlier. Oh, so but I will tell you, no, I have told you already. So you say, no, sir, you haven't never said this. So these things are like a very common event. So try avoiding it. Don't make a mistake of not trusting my words. So going forward, there's one more thing that I'm also interested in this calculation. Velocity analysis, this, that. Okay. Uh, all right. Okay, so let's do some problem, quick problem. So time for some stunts. So you can see that is also a stuntman. And you can see there is a ditch in between. The biker has to jump across it. So this height is h, this height is small h, and the gap is d. Ignore the size of the biker and the bike wheels and all. Find the minimum velocity v naught, of course the horizontal velocity, so that he lands safely on the other this building. Maybe it's which movie? The race, no, this movie. Fast and Furious. Yeah. So you can jump from the first building and land on the second building safely. So what is the minimum velocity V naught you need to achieve this? Am I audible?
Yes.
So can you solve this question?
Yes.
Go ahead. Harshit, are you there? Harshit and Sir, both are you?
Yeah, sir.
Okay. Solve this.
Sir,
Yes, tell me.
so the answer will come in the form of D, H, and G.
Yeah, of course. Why not?
So I'm getting some absurd answer. Should I say?
What is absurd here about it? So we have something very simple. We have to go from here to here, right? So we know that the range is D and the height you have fallen down is H minus H.
H minus small h.
So we know the range is V naught into time of flight and the range is D. V naught we are looking for time is 2H by G. That's it. So V naught is how much?
E under root
T
G by
upon.
2H minus H.
This is not weird. This is nice answer. Okay. So you can say D under root G by 2 under root H minus H. That's answer. So minimum means you just should land here, right, at the edge. If you have more velocity, you will land somewhere here, which is not required. So for the safe jump, this is what we need.
Sir, and if
So not a
the bike, sir, and if the bike had some like measurement, then we had to just add the measurement
yeah.
in that range.
So in that case, the rear wheel should land here safely. Like if you want to safely jump, then the rear wheel must be here, right?
Yes,
So this
like
is the
d plus
safety,
some
na? Because
x
if the wheel is
variable.
behind, you may fall. So yeah, so in that case, the range will be slightly ahead. So what we do is, we will take a range up to here. Like we can add the dimension of the what is this bike.
Bike.
Okay, so let's call this something called d naught. So instead of d, we will write d plus d naught. That's okay. Because you want to go slightly ahead, so v naught must be increased to go d naught extra in the same time, isn't it? Clear?
Yes.
So let's play something because I think you guys have time already tired. So this is our basketball court. Okay, let's get into some court style stuff. I don't know how exactly it looks like. All right, so it's a nice looking basketball court. So if you want, I can add some, yeah, net also. Good enough? Yeah. So now what is given is, let's say the height of the basket is, let's call it, how much meter is the ideal height? I don't know. Okay, I'm taking slightly more height for the solving question. That's too much.
10.5.
Maybe how many meters? Like in meters, we can say,
8.5 meters.
okay, let's call it 8.5 meters. And now there is a fellow here standing in front of this basket. So you're standing somewhere here. So he's throwing the ball. Okay. And his height is 1.5 meter. So the question is, at what velocity he must throw such that it exactly lands the basket horizontally. It reaches here horizontally. So with what velocity you must throw? So they're asking v naught. You must throw, and it is given that the distance between the man and the basket, let's call it 20 meter is okay. So we are trying to create a realistic situation that you're throwing something in such a way that it is reaching the basket horizontally. That's my goal. So with what velocity you must throw? So at first go, it looks like this is not a problem of horizontal projectile. But if you look at the reverse process, think the ball is coming from basket and towards the man. Can you think that the ball is coming from the basket towards the man? Then this is the question of horizontal projectile. So it is horizontal projectile in the reverse order. And then V naught becomes the final velocity actually. Okay, I hope you have not understood.
Understood.
Okay. So when it is reaching the goal post, it will have some speed v. Now that v will act as the velocity of projection for the horizontal projectile motion. So the question is, what is the okay, maybe I need to, I think maybe they should give velocity. They may ask you angle theta, or maybe not. I think no, that's not required because time is given and all. Yeah. Okay, so we can find the v naught easily, right? V naught is very easy to find. Yeah, yeah. You can directly find the velocity v naught. So
Sir, we have to
this
take
question,
GS10.
yeah, take GST. So can you solve this question? Or you can think of solving this question. Not very difficult, but yeah, it's interesting.
So first we have to find V naught and then the theta.
Yeah, you can find v naught first, and I think theta is not required. I think if you can find v naught, your job is done. So here, what is given to you is the h and the range. If you look at the reverse process, the range is given to you 20 meter, and the h is how much? Can you guess the h?
7 meter.
Exactly, that's 7 meter. So you have to use h and r to find the other thing. So using h and r, what we can find? We can find the v actually, not v naught, because we can use the initial velocity v, and then using the reverse process, we have to find v naught. So it's not very easy, but it's interesting. So there are various other ways to solve, up to you.
Sir, I got the answer.
Okay, tell me the answer.
So last
Yeah, just value. Use calculator to calculate Newtonian emission.
sir that I have to just calculate the last step.
Yeah, go ahead. Okay, so
So 16.7
maybe,
meter per second.
maybe.
So what I did first, I found the time of flight, and then by using r is equal to v naught t, I calculated the v naught.
Okay, so R equals to not V naught. That's the wrong answer. R is VT actually. It's a reverse process. This is your initial velocity. If you look at the projectile motion, horizontal. It is horizontal projectile in reverse direction. This is horizontal projectile in reverse direction. And we can find the answer V easily. So we know range equals to V into T. So range is how much? 20. V and T is how much? 2h by g. So V turns out to be 20 upon 1.4. No, I will not solve this. I mean, further. And what is V naught? So V naught is actually final velocity, which is actually V square plus 2gh, if you remember. Or you can derive from basic as you wish. So it's 20 square, which is 400 upon 1.4 plus 2 into 10 into gh. H is how much? 7. So V naught turns out to be, okay, 4000 by 14 plus 140. Okay. So it's a bad answer. Yes.
Sir, I also got the same equation, final equation. Sir, I'm getting 12.1,
So this is coming as 20.63. It's a slightly tricky one because what I did was actually you will get to know that this can be solved easily by other formula. Okay, so other formula says that because it's going horizontal, so this is the maximum height. So we can add the formula, but for that I need to know the theta also. So there is something called maximum height formula and the range formula. So yeah, we can leave that part. So we'll do it otherwise, I mean, in other method also later on by learning the oblique projectile motion. Okay, so let me give you some interesting real world problems, like not the typical Verma type of problem, which is so boring. But what I'm going to give you requires a calculator for calculation because that will have really bad values. But that's how it goes in the US. So they believe in calculator. They don't believe in the human calculation. But their problems are really nice, like with real world touch. In fact, they take the real world problems only from some event. They will not take something random, like which doesn't make much sense. Let me see if I have some books. Oh, this is check. This is very check. Okay, anyway. I don't know where is that. Okay, it's somewhere else. I need to check in other folder. Okay, no problem. Okay, so I mean, I'm not finding where I kept this PDF, but I'll share you soon. Okay, so I have a really nice PDF. You will have colorful pages. You can see questions, and then you can solve. Yeah, I think I got it. Just okay. So I'm sharing the PDF. It's a really big PDF, not need for everything. You can learn something. So I will tell you the page number. So this is the most standard text for first year graduate student of US universities. Anyway, so you'll get it, and then you can go and check the projectile motion section. It is somewhere around 70 page number 70 to maybe 90, and then you need to solve those questions. Okay.
So have you sent the
Okay,
PDF
so we're
on the
done with
group?
the first part. I have sent. It will take some time. I have sent to group only, so you all will be receiving. And it's like the best book ever for the dynamics, statics, and all. The entire chapter is not required because that's for their own graduate syllabus, mostly in the Harvard or Stanford and Boston. Our concern is only the first few chapters, so we'll see only those things. Okay. All right. So this is slightly advanced also. So not everything is required. You can do easy stuff and leave the difficult one. And it will have all the colorful pages. If you want, you can have colorful pages. You can see that might create some interest. Okay, so I'm ending the lecture here only because I will not start the other part before you practice some of the questions. So solve questions of horizontal projectile